Welcome to Operations and Supply Chain University. I'm Jerry Wright. This is lesson number 18, mistake proofing. Oops, here are some mistakes. I like to show these because they're funny. We have Africa listed as Asia. We have thirst place for a metal, spoons, which are clearly knives, left pointing right and right pointing left. Do not stack. You had one job. And then this end up, or do not enter only. I don't know how you get into that place. And more oops coming soon. If you have a safety concern, the best thing to do is pick up a forklift with another forklift and have some guys hang on it while you try to move tanks to a mezzanine. OSHA loves when you do that. Or for these fellows, it looks like they're in the UK or maybe somewhere else in Europe. They've floated their power cord on a couple of flip-flops so they could have their hibachi in the center of an inflatable pool. That's just an accident waiting to happen. One of my favorites on the upper right, you can see a gentleman's on an aluminum ladder in a swimming pool with a sawzall or some kind of corded saw with the wire hanging in the pool. Of course, he has safety glasses on, but I'm not sure they prevent against electrocution. And you can see some other challenges down below. Again, these are mistakes about to happen. So what causes mistakes or errors? Forgetfulness. We can forget steps of the work instruction when we're not concentrating on the task at hand. We could have a misunderstanding. We might jump to conclusions or not ask questions, and that can lead to inadequate training or making mistakes. Identification. Maybe we can't see the item very well or didn't take the time to properly identify it. We have amateurs. Think of temporary employees, new employees. They're just new to the job and they simply lack experience to know what to do. We could have willful. Rules and work instructions are just ignored. Inadvertent absent-mindedness. So you didn't really know what happened. Oh, I guess I wasn't paying attention. Slowness. You could have delays in judgment, maybe even physical or medical issues that are causing a challenge. Lack of standards. Maybe we don't have good work instructions. They're either not available or just not used. Surprise errors and equipment malfunctions, a machine goes down, something like that. And then there's intentional, deliberate acts or sabotage. Now, I say always, if you have someone who's doing willful and intentional mistakes and errors, you need to promote them to one of your competitors. You don't want them working at your business. So how can we prevent mistakes? Errors are inevitable. There will always be mistakes because there will always be humans. It's just the way it is. So let's just focus on how we can prevent or detect them because we're not going to be able to eliminate them completely. Any type of mistake that people can make can be reduced or even eliminated with Poka Yoke. Poka Yoke, we'll explain that in a second. It basically means error-proof or mistake-proof. Now, the first thing is we employ 100% detection or inspection. We use inexpensive Poka Yoke devices or systems to automatically check for errors or defective conditions, and I'll show some examples. We can do a line stop where we pull the andon cord and say, okay, stop, we have an issue. And then while the trail is hot, before the trail goes cold, we can find out what's going on and get it fixed. And ideally, we don't resume operations until we correct it. Usually those kind of things are something that can happen quickly. Sometimes they're a bigger deal. Then we also can have systems and controls like computer systems, barcode scanners, smart data entry, different things like that can really help prevent problems. So Poka Yoke or mistake proofing. So Poka Yoke was developed by Dr. Shigeo Shingo. We just talked about him in setup production. He was one of the developers of the Toyota production system, and he really did this to help prevent errors and defects. So Dr. Shingo was really thinking about how things happen and how they can be improved. Now, it literally translates in English or from Japanese to English as to avoid yokeru, inadvertent errors, poka. So it also can really mean mistake proofing. Now, Poka Yoke means we design processes and products in ways to make errors difficult or even impossible to produce. Poka Yoke can take the form of prevention or detection. So in detection, we make it obvious that an error has been made so it can be corrected. It's a technique for avoiding simple human errors during work, and it respects the intelligence of all of our workers by taking over those repetitive tasks and eliminating errors. It frees up time for our teams to be doing more value-added activities, and it should be employed whenever defects are difficult to prevent or difficult to detect. As I said before, prevention, that's ideal. Make it impossible to cause a defect. And there's many ways to do this. We'll talk about some of those. Guide pins, limit switches, template scanners, data entry, shadow boards, torque tools, all kinds of things can happen or be used to prevent problems in production or prevent errors. Now, detection, not as ideal as prevention, but still good. We have some kind of warning or alarm if a defect is produced or about to be produced. Now, this is a process we use if we can't prevent. It's usually a bit more difficult to implement and takes more thought. So let's look at some Poka Yoke or mistake proofing examples. Here's a couple. I got to go plug a grounded plug into an outlet. I can only plug it in one way. Now, in order to put it in upside down or incorrect, I have to file down one of the blades. I have to cut off the grounding plug. That's the only way I could not do it correct. It takes a lot of effort. That's a willful intention, right? Now, maybe I've got a surgery coming up. I have all the tools. I have them marked. I have a photo of them before, and then I check to make sure I have all of them afterwards because that's the right way to do it. I don't want this. That's a pair of forceps left inside a patient's body cavity. That's an uh-oh, we don't want that. Now, other forms of detection could be like a Cognex or other vision system that looks at the box of candy and says, are there 4 pieces in there? Yes, there are. Okay, if not, it alarms or it kicks it off or stops the line. Another one that's common that we've seen, and you may have seen in industry, is scales. As the box goes across the conveyor, it has a weight to it. It's pretty sensitive, and it says, "Oh, hey, it's too heavy or it's too light," and it either kicks it off or stops the line. Now, an interesting story to share with you is I had a colleague who had one of these kind of scales in place, and every afternoon in the summertime, the scale would start failing, and they didn't understand why. What they realized after some problem solving, they did their 7-step problem solving, and they found out that they had a big overhead fan that was blowing air, and it blew enough air down and put enough pressure on the box that it made the scale think the box was too heavy. So they had to install basically like a cover or a deflector over the scale so that the air blowing down would go off to the sides and not affect the weight of the scale. So again, a great system. So here's mistake proofing levels. Here's an example of a road. And then if you can see in the foreground, there's some railroad tracks. There's nothing there. There is no mistake proofing, no signs, nothing. And if you had a large row of trees or something and you came around the corner, you may not see that there was a train there, particularly if you had your music on loud or something like that. Well, how could we improve that? Well, we could put some signs up. Here's some mistake proofing. There's some detection or some warning signs. We could obviously improve on that. Most people say, hey, we could put in a crossing system. Okay, that's better. That's more mistake proofing, but it's not full prevention. Why? Because people can drive around the arms. Sadly, trucks and other vehicles drive right through the arms and have hit trains. It's not what we want. To get full mistake proofing, we need to put in a bridge or an underpass. That's the best way to go. Now, we don't have bridges at every intersection of vehicles and trains because they're very expensive. A simple bridge like this could be millions of dollars. But that's the aim we want to have, is full mistake proofing. Now, if you do mistake proofing, you should be able to answer yes to all of these. It prevents reoccurrence, it's inexpensive, it's made with wisdom and ingenuity. That's a Dr. Shigeo Shingo expectation. It's simple, easy to implement, durable, easy to maintain, does not hinder the operator, gives prompt feedback, gives prompt action, maybe prevention if we can get it. Focused application has everyone's input. All the operators and experts and technicians have had their input. It's reliable, it doesn't give false signals, and it doesn't cause some other problem. That's a pretty hefty checklist to do mistake proofing, but that's the aim you want to have because mistake proofing is very powerful. It eliminates or prevents defects to a great degree and then detects those that we can't prevent. Fantastic and amazing tool. Highly recommend you look into it. So what's the approach you want to take? Here's the mistake proofing methodology. First of all, calculate your first pass yield, or FPY. First pass yield is everything, say, in a production line that you shipped, divided by total products that you made that day plus rework plus scrap. Now you can imagine as rework and scrap go to 0, my first pass yield goes to 100. Do we ever get to 100? Maybe on a ship, on an occasional shift or day or something here and there, but it's tough to get to 100. So what you do is you accurately track your rework and scrap, and then we can look at Pareto diagrams. So you can put a Pareto diagram together. What are the primary causes of scrap, primary causes of rework, and then we can identify opportunities for Poka Yoke or mistake proofing. Use your Poka Yoke principles along with Lambda. Remember, look, ask, model, discuss, and act, or DMAIC, define, measure, analyze, improve, and control, as well as Kaizen to reduce errors, scrap, and waste, and start driving that first pass yield towards 100. Just a fantastic way to boost quality, reduce scrap, and reduce rework. If you want more information on mistake proofing, there's a couple of books. There's no authors listed on here, and I'm not sure why, but if you go to Amazon or other booksellers, you'll find, if you type in mistake proofing, you'll find a couple of resources out there to look at. Again, great books. Definitely get a chance to dig into these if you can. That's it for mistake proofing. Thank you.